So lab 2 is on biologically relevant ions, and we will explore the ions that we can identify in a vitamin solution, a multivitamin solution. And so even though it's lab 2, it does not need exactly lab chapter 2 knowledge, but more chapter 3, right? Ions and ionic compounds are part of chapter 3. And so here it shows you a table with elements that are needed in your nutrition. And they are classified as essential elements in gray here, and then trace elements. And you can see that the trace elements are needed in a much smaller quantity per day than the essential elements. And so then you will have to watch a video that shows how the vitamin solution is prepared, and the link is here. And it uses filtration. And so you want to read all of this before you start the lab to, you know, not have questions that can be answered there. So the post-lab part is this. And here, put the name, your name, and the vitamin solution preparation. So you will see that on that video where I prepared the solution, I tell you more than, I think in the video it's not very clear how the solution looks like, but hopefully using my words you can write your observations of the appearance of the vitamin solution here. In that line, okay? Then you will fill the tables, and for this you need to watch the video as you have your table ready. And this first table B goes over what colors the flame will be when you are burning solutions that contains potassium, barium, calcium, etc. So you want to have the correct flame color for each ion. And then we are supposing that we will do the vitamin solution and put it in a flame. And there is no videos showing that. So you have to take the words that are written here, that are the observations if you were putting the vitamin solution in the flame. The flame would be an orange color or a yellow-red color. And so given that information, you want to find the ion that matches that color in the list above, in the table above. And so given that flame test observation, then you can identify only one ion. It should be identifiable this way. So write down the ion that has this flame color. Table C, it's aqueous test to detect ions, positive ions, metals, by using sodium hydroxide. And so here there is the video again that you need to watch. And yeah, I have precipitate written here. So typically what you will observe is that you have clear solutions. So a solution that contains the ions listed here on the left. And then the NaOH solution is also a clear solution. And when you mix two clear solutions, sometimes you see a cloud forming, like the solution is not clear anymore, it becomes opaque, and you see a thick mass obscuring the visibility through the solution. And this is called a precipitation reaction when you observe that. And what the powder that is forming inside the solution is called a precipitate. And so in the videos, sometimes they have this abbreviation PPT. PPT means precipitate, and it's referring to that solid that is formed when you are mixing two clear solutions. So I have the word here for you to know how to write it. So all these observations are about, did you see a precipitate, and what was the color of the precipitate? And that's what you want to record. And then when an excess of sodium hydroxide is added, what happens to the precipitate? Then the last column here is asking you to make the formula of the compounds that are made from the ion listed on the left and the hydroxide ion, the OH minus ion, because if there is a precipitate, it's from that compound. And so here, when you do a formula, you always put the, let me make it straight. You always put the positive ion first, and then you add the negative ion second, and you do the crisscross trick. So here you would have Al3 plus and OH minus. Minus here is a superscript. And when you do the crisscross trick, the 3 from the Al3 plus becomes a subscript for OH. But because OH is a polyatomic ion, you need parentheses around OH. And then the 1 from the negative charge of the hydroxide ion becomes a subscript for Al. But when you have a subscript of 1, it's implied. We don't write it. So here, the formula for the aluminum hydroxide compound would be Al's OH 3 times, for example. And yeah, here I had this earlier to explain that what this formula means is that you have 1 aluminum 3 plus ion for 3 3 hydroxide ions, right? The formula has to be neutral. So what is important when you fill that column is that you are putting the subscript in subscripts. I don't want a large 3 here. I want a 3 as a subscript. So make sure you know how to use those formatting tools here in the font editing tool. You want to use those x2 or x square, you know, if it's a subscript, use x2. If it's a superscript, use x squared, right? It is important that you format properly for me to consider this correct formula. So, so for ammonium, it's a bit more complicated. It needs to go through testing with the litmus papers. And so litmus papers, there are 2 kinds, the red litmus paper and the blue litmus paper. And you need to tell what color they become when they are exposed to the vapors that come out of the test tube. Are they staying the same color, or are they changing color, and what color they turn into if they change color? Okay, so that's for ammonium. Again, when you need to identify the ion that was most likely present in the vitamin solution, you will need to read the observations that were made for the vitamin solutions. It's not part of the video, and there is no video showing that. So you need to take the words here, and from these descriptions, find which ion corresponds to those observations, right? There is only one ion that should fit these descriptions. So table D, it's the same thing, except the test is using ammonia this time. And you need to find the observations for each ions. And again, when you are ready to identify the ion that is most likely present in the vitamin solution, you need to compare the observation written here. A white precipitate was observed, but dissolved with an excess of NH3. So find which ion there has the same observations, and then that will be your ion that you want to write down here. Same thing here for table E, except this time we are testing for the presence of anions, which are negative ions. So make sure you fill each box here. For those anions test, there were 2 kinds. So make sure you watch the whole video to see all the tests. And again, you will identify the anion present in the vitamin solution using the observation given here. Only one ion should fit these observations. And same with carbonate. For the carbonate, you need to say if it's present or not. For the post-lab questions, question 1 refers to the fact that the solution, the vitamin solution was not exactly looking like water, right? The way you would describe water, for example, is that it's a clear, colorless liquid. So I want to emphasize what clear means when we are saying a clear solution. Clear refers to the transparency, or can you see through the solution? And so clear means it's transparent, you can see through, it's totally visible through the solution. So that's what clear means. It has nothing to do with the color. You have to specify the color of the solution. You can have a clear solution that is blue or red or pink, and that is still clear, right? So these are two different observations. And so when your solution is not clear, then you can describe it as cloudy, opaque. Opaque means you cannot see through anymore. It's blocking the light and anything that is behind. And you see, for example, that when you are seeing a precipitation reaction, you see a thick mass obscuring the visibility of your solution. And so all of these describe what happens when you see a precipitate. When you see a precipitate, it will, you know, make the solution cloudy. The powder forming in there will make the solution opaque, and it will completely obscure the visibility. So that describes what a precipitation reaction is. But this doesn't tell you about the color. The color of the precipitate could be different than white. It could be blue, green. And the solution could still have a different color too. The solution could still be, you know, brown, pink, blue. And so you have to take into account that the precipitate itself can have a color, and the solution also can have a color. So for example, if you start with a clear blue solutions and a white precipitate is forming, the precipitate may look a little bit like it's blue, but that's from the solution. However, you can tell the difference. If, for example, your precipitate is blue, inside a blue solution, you can tell the difference between a white precipitate and a blue solution. So think about that when you are imagining what will happen when, for example, a white precipitate appears in a colored solution, right? So that's what I want you to think about. I know it's not easy because that's really something you want to observe in a lab. But here, I don't have pictures of that. And so I want you to try to imagine how, you know, seeing a white precipitate in a clear solution that has a color, what would you see? So question 2 and 3 are similar, and they are, you know, straightforward. You need to look at the piece of video that goes over the detection of the ammonium ion using NaOH if you need help answering that. Same for the carbonate. Go back to the video that use the test with HCl to detect the carbonate to answer that question. So during this lab, you will detect the presence of 2 cations and 1 anion. So I want you to remind the formulas of the, you know, the symbols of these ions that were detected. And I want you to specify if they are essential elements or trace elements. And for this, you will go back to page 1 and 2 of the lab, where you have the tables that tell you if it's an essential or a trace element. Then question 4b, you want to make compounds with those 2 cations and 1 anion that has been detected. And so because 2 cations can combine each with the anion, so that means you can make 2 compounds. So I want you to find the formulas for those 2 compounds and give their names. And finally, I want you to choose a medication, a nutritional supplement, a bathroom product, or a cleaning agent from your house. So you have the choice. There's no way you cannot find something. List the ionic compound. The names, most likely it's going to be a name, and you need to find out what is the formula for that name. So be careful to not list any covalent or organic compound. For example, if you choose a medication, you may see a lot of names that will not be ionic compounds. So make sure you recognize ionic compounds. They are made of metals and non-metals. The organic compounds or covalent compounds will be made of just carbon, nitrogen, hydrogen, oxygen, maybe sulfur and phosphorus, and will be not ionic compounds. So make sure to not list those. So for example, somebody was asking me if I used toothpaste. Yes, toothpaste would be a good example. And so make sure you look at the active ingredient and then the list of inactive ingredients. For example, if you most products are like that. You have an active ingredient and then you have a long list of inactive ingredients or less important ingredients. And so look at those 2 lists, right? And so that will do for lab 2. And submit as one file. If you do it on paper and take pictures, make sure you submit your lab report as one file with the different pictures into one file. But I think most of you can edit the Word document. So otherwise, I'm available by email if you have more questions.